Hello, class. Well, in our last lesson, prior to the test, we wrote linear equations given a point and a slope. In this lesson, we're going to investigate relationships between quantities by using points on scatter plots. So let's go ahead and get started. I know this is an unusual video. This is the first one I'm doing for most of you all who are on this extended break here for the COVID-19 or the coronavirus. And so you probably don't have a note sheet in front of you. I'm asking you to go ahead and take notes in a notebook or on a separate sheet of paper and keep those around for your own reference. I'm going to try to keep the writing to a minimum. And as always, you can come back and check the video if you have any questions. So let's get started. Starting off, of course, with our new vocabulary. So, three new vocabulary terms here today. We're going to start with bivariate data. Bivariate data is simply data that has two variables. It could be something like time and temperature, could be time and distance, could be money and the number of chinchillas that you bought. Anything that has two variables in it would be considered bivariate data. And of course, this being Algebra 1, we're probably going to call those X and Y. Next is scatter plot. And a scatter plot is a visual representation of the relationship between two sets of data shown as ordered pairs on the coordinate plane. Okay, you've seen these a bunch, I'm sure. They've got dots all over them, and we're going to see a bunch of them in this section. And lastly, correlation. Correlation is the relationship between two sets of data. And unlike most other relationships where the relationship can usually be, well, complicated, in this case, the relationship between the data is going to be positive, negative, or no correlation. Okay, no correlation. That's kind of like when all the dots are having social distancing. Okay, looking at the types of scatter plots. If your scatter plot looks something like this, and most scatter plots are going to live in quadrant 1 of the coordinate plane, so you're going to have a positive x and a positive y. If your scatter plot looks something like this, where it's generally trending up, going left to right, okay, a line through the dots would have a positive slope. That is considered a positive correlation. If they're trending generally down, going from left to right, that would be a negative correlation. Okay, the line going through them would be that negative slope. And if they're practicing that social distancing, that would be no correlation. The dots are kind of just spread out all over the place. Nothing really good going on here. In addition to that, you can have a different strength for each correlation. So for instance, over here, you can have, for these two, you can have a strong positive and a weak positive. You can also have a perfect positive. You can also have a strong, a weak, and a perfect weak correlation. And if it's no correlation, well, it's just, well, no correlation. And the difference between strong and weak is just how close they are to a given line, okay? If they're really, really close to a line, maybe not perfectly on the line, that'd be a strong correlation. If it's a little further scattered out, okay, it's generally trending up, but it's not sitting like directly on the line, that's going to be weaker. And if it's sitting dead on the line, you've got a bunch of data points that are exactly on a straight line, that would be a perfect correlation. So depending on how close the data points are to a line of fit, that's going to determine the strength of that correlation. Okay, let's take a look at our first example. The graph shows the average number of students per computer in Maria's school. Determine whether the graph shows a positive correlation, a negative correlation, or no correlation. If there is a positive or negative correlation, describe its meaning in the situation. So let's take a look at this. If I'm looking at these dots here, those data points on the graph, if I were to draw a line down through those, I can see here that that's generally going something like this, okay? I'd say that is a negative correlation. It's going down left to right. I'd even say that's a pretty strong negative correlation. None of those dots are too far off that line. So let's see what the answer here is. So it's going to be, oh, and what does that mean? Well, as the years are going on, the number of students per computer is going down. Okay, so that rate is decreasing. So if the number of students per computer is going down, that would either mean there are fewer students in the school, which is possible, or there's more than likely more computers in the school. And of course, the answer is going to be something like this. The graph shows a negative correlation. Well, we said that. It was going down left to right. Each year, more computers are in Maria's school, making the students per computer rate smaller. And that makes sense based on what we're seeing in the graph. Okay, take a look at a real world example number at this next example. The graph shows the number of mail order prescriptions. Determine whether the graph shows a positive correlation, a negative correlation, or no correlation. Describe if there is a positive or negative, if there is a positive or negative correlation, describe it. Well, looking at this, well, look at that. Those dots, man, that's about as close to a perfect positive correlation you're going to see. Look at those. Those bad boys line right up there. Boom, 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 boom. I'd say that's close to a perfect positive correlation. Let's take a look at our options here. Positive correlation, negative correlation, no correlation cannot be determined. Well, that is definitely a positive correlation. But as the years go on, 95, 96, 97, 98, the number of prescriptions goes up. So, of course, our answer here is going to be A. Positive correlation. With each year, the number of mail order prescriptions has increased. Okay, and now we've got our SAT question. Which of the following graphs best shows a strong negative association between D and T? Well, association is another word for correlation. Okay, you can use that. So how are D and T associated? How are they correlated? Well, I'm looking for a strong negative. Strong negative. So if I look at our different options here, A appears to be going down left to right. So that is negative, but it doesn't look real strong. That data is kind of scattered all over the place. B, I got, one of these things going on. It starts off negative, but then it starts going back up. C, oh, that's doing one of these. That's positive. So it's not this one. I'd say it's not this one. D is also negative. And if I look at the difference between A and D is more tightly bunched. Okay, that is definitely a tighter correlation. And the note here says the tighter the data, the stronger the correlation. So D is stronger than A. So I would say our answer here is D. Okay, so there you go. That does it for our notes here. Your practice assignment for this is going to be in Delta Math, and I will talk about that in a minute. Okay, so on your Delta Math assignment, you're going to be asked to determine whether each scatter plot has a strong positive, weak positive, perfect positive, strong negative, perfect negative, weak negative, or no correlation. Just asking you to take a shot at a dozen of those, and it should be pretty straightforward. If you have any questions, of course, the Delta Math videos are available for you, and I will talk to you later. Good luck. Thank you.